of lecture number 12. In last lecture, we have started with single phase full converter RLE load with continuous mode of operation. Now we will discuss what happens when the output load current is discontinuous. That means my output load current goes to zero before the next SCR is triggered. Okay. So in this case, your RLE load will come into picture. Now, we have already studied why does this happen, that why does the output goes to zero at beta, because of the inductor stored energy, right, being limited, and that keep being releasing the energy of the negative half cycle, and then the current goes to zero. And then again when the SCRs are re-triggered or the next set of pairs of SCRs are turned on, again the current starts rising and the same pattern will repeat. So in that case, assuming that either T1 and T2 or T3 and T4 are on, these are all SCRs, T1 to T4. So we can write an equation V out is equal to IR plus L di by dt plus E, correct? Now, under the assumption that all these SCRs are, either of them are on, all of them cannot be on. If all of them are on, it will create a dead short circuit across the supply. That is not what we want. That will destroy the load as well as the source. What we want is controlled fashion, either two of them on, right? So in that case, when this happens, my output will be equal to, actually in this case, what equation which I have written, T1 and T2 should be on. Why? अगर T3 and T4 on होते तो इधर minus sign आता, because this will be minus Vm sin omega t. So this is valid for when T1 and T2 are on, output is equal to input Vm sin omega t minus E. मतलब इसको overcome करना पड़ता है voltage को. Then it will be equal to IR plus LDI by dt. So this inductor releases that energy during negative half cycle. Also, on top of it, it has to overcome E. So it has double job to do. Okay. So now we'll understand what happens between 0 to theta 1. Now this is 0 to theta 1, right? 0 to theta 1, what is happening? V in is less than E. मतलब क्या हुआ? V in is less than E. Reverse bias है सारे diodes. Reverse blocking mode में. All the diodes are off. So what will be your output voltage ideally? नहीं, 0 नहीं है. See, between omega t between 0 and theta 1, that is E, V in is less than E, my SCR, all the SCRs are in reverse blocking mode. This much is clear. Current is 0, but current 0 matlab VR 0, VLV 0, matlab it will behave as a short circuit. अरे voltage 0 matlab behave as a short circuit ना? Yes. So output में क्या आया? E ना? Yes or no? Correct. So what is my output now? Sorry? Output में you will have E from 0 to theta 1. ठीक है? ये E रहेगा from 0 to alpha. क्यों? Because from theta 1 to alpha, again all the SCRs are off, but T1 and T2 are eligible to turn on. Forward bias हो गए between theta 1 and alpha, right? So till alpha ये output will be E only. ये visible है ना? ठीक है. अब इधर तक ऑपरेशन समझा ना? आफ्टर अल्फा, ये थोड़ा सा अल्फा इज हियर, this alpha which I have written over here, actually this point, okay? This is theta 1 wala, okay? So from 0 to alpha, my output will be E. Output current will be 0, right? Input current will be 0, right? Alpha के बाद it starts increasing. Now T1 and T2 are triggered on. ये जाने दो ना, ये this you have understood, right? Waveform this I need not show that, and E is like this, constant. Now I out, 1 and 2 are triggered on, so current will start flowing. It will increase, right? Also, my output will be equal to input. Output will follow the input voltage as long as T1 and T2 are on. ठीक है? So that is what is happening. It will turn on. It will follow the input till pi. Pi के बाद क्या होता है? Inductor stored energy is released, right? So Because of inductor stored energy, the T1 and T2 conduct till beta. Beta में करंट जीरो हो गया, instantly T1 and T2 are off. Reverse bias है ना, supply आ रहा है ना negative, current भी zero हो गया, right? So what should happen? This behavior V out equal to V in should continue till beta, right? After that, what happens? From beta to pi plus alpha, what happens? Again, all transistors are off. क्यों? T1 and T2 reverse bias की वजह से off हो गए. What about T3 and T4? T3 और T4 are in forward blocking mode, but trigger नहीं आया है, तो off रहेंगे. So between the period beta and pi plus alpha, all the transistors are off. ये ideal state है. Again, at pi plus alpha, T3 and T4 are triggered on. बराबर है? So here it will happen from beta to pi plus alpha, output will not be zero, but it will be E. Same concept, right? And then after that, T3 and T4 are on. What will happen? It will follow minus V. V out will be, अरे ये minus V in का line है ना? ये वाला dotted line is minus V in. This is V in. So जब भी T3 and T4 are on, output will follow negative of input. Till they are off. अभी off कभी होते हैं pi plus beta में. And the cycle will repeat. So load current off कभी हो रहा है? From beta to until the next trigger. So these periods which I have now marked, no transistor is on there. And this is the functioning. Yeah, IN will be like this. When T1 and T3 and T4 are on, I out will be opposite of, IN will be opposite of I out will be opposite of IN. Sorry, IN will be opposite of I out. ठीक है, reverse current है ना? Reverse current in the sense supply change हुआ है ना? या पहले positive negative था. Now we have negative half cycle. So input current direction will reverse. Output current will remain same in the same direction. Why? SCR है unidirectional device है. They allow the current only from anode to cathode and not other way around. So the current flowing through the load will always be from C to D. Whereas in the positive half cycle, the current will flow from here, A and T1 and all, and in a negative half cycle, the current will flow from B, T2. So see, current direction has changed, right? So this is what will happen. This is what happens. Just draw this V out waveform. For this continuous I out and V out waveforms. Quickly. This is same as RLE load, half wave controlled. इसमें खाली full wave controlled है. That's it. Quickly draw the waveforms. Your RLE load is coming into picture now. In continuous mode, why it was not coming, you understood now. So load current negative जा ही नहीं रहा. Because यहाँ पे SCR automatically turn on नहीं होते, हमें turn on करना पड़ता है by giving the trigger pulse. उस time तक current zero रहता है. Whereas in continuous current mode, current तो है ही, तो SCR off ही नहीं होते, on ही रहते हैं. Any two at a time will be on. इस केस में कुछ wherever SCRs are off, current will be zero. Drawn? Very good. So these all things you have explained. You all can refer them later. Observations are from alpha to beta, T1 and T2 conduct, output will be equal to V in. From pi plus alpha to pi plus beta, T3 and T4 conduct, output will be equal to minus V in, right? Is there a minus sign रह गया इधर? Correct ना? Minus आएगा नहीं आएगा? We can write magnitude of V. Correct? And then ideal period, so what I was talking about, right? From 0 to alpha, no SCR conducts, output is equal to E. From beta to pi plus alpha, No SCR conducts, output is equal to E, and pi plus alpha to 2 pi plus alpha. But we are waiting for a trigger pulse to arrive. So this is the ideal period. अभी इसके derivation is also similar. V out average and VRMS. I'll recommend you all to please derive it. I'll include in the derivation. I'll include the derivations later in this handout. But output average waveform, average value and RMS value के derive कर सकते हो. Similar to RLE load. I'm not showing that right now. You have any queries before I proceed? कौन सा? Okay, fine. I'll explain. I have to draw it over here. Let me quickly draw it. It will hardly take any time. Positive है. It follows minus V. अरे ये वाला देखो. This part is V. और ये dotted line कौन सा है? अभी समझो. आउटपुट इज पॉजिटिव बट फॉलो क्या कर रहा है वो इंपॉर्टेंट है. अभी समझा क्या? पूरा समझाओ. समझाओ. अच्छा. अंडरस्टूड ना व्हाट आई एम टॉकिंग अबाउट? आउटपुट पॉजिटिव ही है और नेगेटिव हाफ साइकिल में नेगेटिव को फॉलो कर रहा है बीन को, पॉजिटिव हाफ साइकिल में पॉजिटिव बीन को फॉलो कर रहा है. दैट इज व्हाई वो डॉटेड लाइन इंपॉर्टेंट है. डेकोरेशन के लिए नहीं, इट हैज अ मीनिंग टू इट. समझ में है? दैट इज व्हाई वी राइट व्हेन T3 and T4 आर ऑन, आउटपुट फॉलोज नेगेटिव ऑफ इनपुट. एक्चुअली नेगेटिव हाफ साइकिल में वो फॉलो इनपुट ओनली. नेगेटिव हाफ साइकिल में इनपुट इज नेगेटिव ओनली. बराबर ना? सो दैट्स व्हाट इट इज रिटन ओवर. ठीक है. नेगेटिव हाफ साइकिल में इनपुट इज नेगेटिव, आउटपुट इज negative of input when T3 and T4 are on. I was about to explain you from here, from the diagram, कैसे होता है. अभी 2 मिनट नहीं चाहिए तो ठीक है. ठीक है, क्या बताओ? एक बार बताइए. हाँ, पक्का समझ. बिकॉज यहाँ पे पोलैरिटी रिवर्स होता है ना. बराबर है. अभी 1/10 शॉर्ट सर्किटेड एंड ये पॉजिटिव नेगेटिव, ये पॉजिटिव नेगेटिव रिवर्स हो गया. बराबर. Okay, so now we completed the topic of full converter with R, RLE and RL load, with discontinuous and continuous mode and with freewheeling diode. Now we'll come to performance parameters. Write down the topic, performance parameters of single phase full converter. What do you mean by full converter? Full wave control rectifier का short form is full converter. Or in the books it's called as two pulse converter. Half wave rectifier is called as one pulse converter. Full wave rectifier is called as two pulse converter. Other name is full wave control rectifier. Barabar? And then this name is full converter. In this derivation, in this performance parameters, we are assuming two things. RL नहीं तो RLE load है. अभी RL और RLE load से same for continuous mode of operation, right? Second thing क्या assume कर रहे हैं? Continuous load current. ये दो चीजें याद रखो. Okay? So far, we have observed that even though the AC input supply is purely sinusoidal, देखो हमारा input supply ये dotted line इसमें input supply ना, ये V है, बराबर है? It's a pure sinusoidal, right? Without any harmonics and all that, right? It's purely sinusoidal. But मेरा input current sinusoidal है? Input current is sinusoidal? No, it's not at all sinusoidal. It contains harmonics, and that is what we are going to analyze. Harmonics को analyze कैसे करोगे? By Fourier series. Even and odd harmonics, right? So this In is my input or source current. This is my output or load voltage, and this is my load current, output or load current, right? So which all things contains harmonics? Output current, input current, and output voltage. यही तो बनाया ना? It's not a pure sine wave, right? So anything which is not a pure sine wave, it contains fundamental plus harmonics. So that is what we have to do. The input source current, load voltage, and output current are complex waveforms. ये complex waveform है ना? This also is complex. This also is complex. That means they contain harmonics. Okay. So the current at the AC input terminal of full converter consists of fundamental component with superimposed harmonics component. You understand harmonics, right? The sinusoidal wave contains a lot of harmonics. It's a mixture of a lot of harmonics, right? Therefore, depending upon the load current waveform, a phase difference will be there between voltage and current. देखो current voltage and current में phase difference है ना? This is my voltage, and see current is starting after alpha. Yeah, this is what alpha na. क्या ना difference? Correct, right? मेरा input है कितना phase difference? Alpha difference we call it phi. Right now we are calling it phi. Okay. So therefore, ये क्यों जरूरी है? Why this analysis is important? Because there are harmonics, we need to define external performance parameters because this is going to affect the performance, right? Because this we will be connecting to RL load or a motor. So we should know exactly what kind of a behavior is my input source current is displaying. So those parameters are measured with respect to external performance parameters. तो दो तरह के होते हैं, input performance parameters and output performance parameters. So let us begin. One assumption, load and output current is assumed to be continuous. Now this is written there, very important. The following derivations are not in syllabus, which are marked in purple color. Whatever I have written in purple color is not in your syllabus. Only the end result and expressions will be utilized. So I will be doing it very quickly. Okay? So we are assuming under steady state conditions, my output voltage is normally a periodic function, right? What is a periodic function? Yeah, so mathematically, how do you write it? Number one, that it's a periodic signal, correct? And normally, all of our waveforms, whichever we have analyzed, are periodic signals. Now, if f is the frequency of the output voltage in hertz, then the angular frequency will be omega equal to 2 upon t, 2 pi by t, 2 pi f, right? This you know. So equation number 1 can be rewritten as v out of omega t is equal to v out of omega t plus 2 pi. इतना clear है? Okay. Now, output V out of omega t is the output voltage of a full converter which contains harmonic. It's not purely sinusoidal but periodic. कैसे? ये देखो. It's not sinusoidal but it's periodic ना? ये periodic है ना? It's repeating itself, right? Sinusoidal नहीं है but periodic है. किधर? T है ना? T is 2 pi. यहाँ पे okay, you are writing instead of t we have replaced omega t. So instead of capital T we should replace it by 2 pi by omega. ऐसे बोल रहे हो? रेडियंस है वो. रेडियंस में 1 t को क्या बोलते हैं नॉर्मली? इन डिग्रीज, राइट? ऊपर वाले में डिग्री बोलेंगे, नीचे वाले में इसमें रेडियंस बोलेंगे. ओमेगा मतलब रेडियंस ना. फॉर्मूला को ज्यादा मत देखो इतना. इट्स करेक्ट ओनली. t is 2 pi, राइट? अब ये हार्मोनिक्स वाला फंडा ये अंडरस्टूड? output is periodic but not purely sinusoidal because it contains harmonics. इसको analyze करना है, ठीक है? And we will analyze this using Fourier series. Now you might have used Fourier series before in mathematics. It's a collection of finite terms plus infinite terms, right? Higher order terms. It's stating है, it states that a periodic function can be described by a constant term. Constant term यहाँ पे क्या रहेगा? DC component, average value, plus a infinite series of sine and cosine terms. मतलब harmonics है ना ये, of frequency n omega, where n is the integer, correct? So this is equation number 4 is my Fourier series of V out of t. So V out of t is छोटे छोटे टुकड़े, harmonics. Your A0 is my V out average or VDC. बराबर ना? It's a DC component, right? Plus summation of n equal to 1 to infinity an cos n omega t plus bn sin n omega t. I think you know. So this is my harmonics. ठीक है? Where A0 is the average value of the output value and the average value of the output voltage. Now these are the formal definitions. इसके मैं detail में नहीं जा रहा हूँ. A naught is 1 upon t, 0 to t, V out of t, dt, right? Where t is 2 pi. ठीक है? But an is V out of t cos n omega t. ठीक है? And it is 1 upon pi. Why? नहीं, it is 2 upon 2 pi. Because एक साइकिल में, कंप्लीट साइकिल में 2 मिलते हैं ना वेव, तो 2 upon 2 pi which is 1 upon pi, but period is 0 to 2 pi. फुल वेव में 1 कंप्लीट साइकिल में 2 ऊपर मिलते हैं ना, तो it is 2 upon 2 pi, that is 1 upon pi. Period is 0 to 2 pi only. Analyze कितने करने हैं? 2 component ना, so that is what is there. समझा ये? Similarly, equation number, these are constants, an and bn. So similarly in bn we have sin n omega t. So equation number 6 and 7, any doubt? If V out of t is discontinuous, several integrations must be performed to determine the constants. But हमारे इसमें continuous है ना, या discontinuous है? In our case, our V out is discontinuous or continuous? Discontinuous मतलब zero होता है? Yeah, it may happen that V out becomes zero. Free wheeling card में zero होता है ना? Zero हो गया तो discontinuous. Continuous मतलब either positive या negative, zero नहीं होना. Now, इधर देखो, we are combining an cos n omega t plus bn sin n omega t. So when you combine them, what happens? You get this an square plus bn square raised to half. अभी ये देखो, ये पता है ना hypotenuse theorem, a square plus b square is equal to c square. तो an और bn को कैसे लिखोगे हम लोग? an square raised to half, bn square raised to half. अगर दोनों को कंबाइन करना है तो an square plus bn square raised to half. बराबर है? तो ये हमारा कहां से आया? हाइपोटेनस, पाइथागोरस थ्योरम. नाउ इसमें से पता है ना, साइन वाला टर्म इज व्हाट? ऑपोजिट अपॉन हाइपोटेनस है, तो an डिवाइडेड बाय दिस. cos is like what? Adjacent ना, हाँ, बेस अपॉन हाइपोटेनस, bn अपॉन, यू हैव अंडरस्टूड राइट? साइन पाई n और cos phi n, हाउ इट हैज कम? तो ये यही लिखा है. This is an upon this and this is bn upon this. So this is cos n omega t plus bn square root of an square bn square sin n omega t. We are just combining an and bn terms. An cos n omega t, bn sin n omega t. Now let us define an angle phi n whose adjacent is bn and opposite is an. तो यही है, हमने यही बोला है मैंने. समझ गया फटाफट? उसका ये क्या होगा? फाई ऑफ एन का एंगल क्या रहेगा? tan इनवर्स, राइट? tan इनवर्स ऑफ an अपॉन bn. adjacent upon base. Now an and bn को कंबाइन कर रहे हैं हम लोग. ये sin phi n कैसे आया पता है ना? an upon an square plus bn square raised to half, यही है ना? और ये cos n cos phi n कैसे आया समझा? राइट. तो there is a this thing sin a cos b plus cos a sin b is equal to sin of a plus, यही लिखा है. इक्वेशन नंबर 10 अंडरस्टूड. सो इक्वेशन नंबर 4 जो था वी आर रीराइटिंग इंटरनल. ये जो an cos n ओमेगा t bn sin n ओमेगा t इसको रिप्लेस करोगे इससे इक्वेशन नंबर 10 से. देख लो कर दिया रिप्लेस. ओके एंड वी आर कॉलिंग दिस an स्क्वायर प्लस bn स्क्वायर रेज टू हाफ एज cn. इसको बोलते हैं cn. ठीक है. cn is an square plus bn square raised to half, right? So this is my complete series. ये मेरा फोरियर सीरीज है रीडिफाइन सिंप्लीफाइड किया, बेसिकली सिंप्लीफाई किया मैंने इक्वेशन नंबर 11. सो v out of t a0 plus summation of all these terms harmonics. हाँ पाई ऑफ n क्या है पता है? डिले एंगल ऑफ द nth हार्मोनिक कंपोनेंट. अगर फर्स्ट फंडामेंटल होता है ना तो फर्स्ट का निकालना है तो क्या होगा? पाई 1 इज इक्वल टू tan इनवर्स ऑफ a1 अपॉन b1. n is 1. सेकेंड हार्मोनिक a2 अपॉन b2. समझ गए ना तुम लोग? नाउ सभी निकालने की जरूरत नहीं है. सर इज समथिंग कॉल्ड एज हाफ सिमेट्री. हाफ वेव सिमेट्री मतलब नेगेटिव वेव हाफ वेव इज अ मिरर इमेज ऑफ पॉजिटिव हाफ वेव. देखा है ना हम लोग ने फुल वेव रेक्टिफायर में. फुल वेव रेक्टिफायर में इट्स अ मिरर इमेज, राइट? सो हाफ वेव सिमेट्री है. Correct? So if it is a half wave symmetric, V does not contain even harmonic. अगर वेवफॉर्म में हाफ वेव सिमेट्री है, it does not contain n equal to 2, 4, 6. Even harmonics are gone. Only odd harmonics remain. समझ में है? What I'm trying to say? अगर हाफ वेव सिमेट्रिक है, only odd harmonic it will have. So due to this half wave symmetric, also average value will be 0. A naught will be 0. हाफ वेव सिमेट्रिक की वजह से. So this is how my Fourier series will look like now. V out of t will be summation of n, which is 1, 3, 5 odd harmonics. Then Cn, you know what is Cn, right? Sin of n omega t plus phi n. This is equation number 13. समझ में आई ये बात? हाँ? A naught ऑड हार्मोनिक है ना. अगर तुम्हारा साइनसॉइडल, लेट्स से साइनसॉइडल वेव है, साइनसॉइडल वेव का एवरेज वैल्यू क्या रहता है? ये साइनसॉइडल नहीं है. वी आर कंटेनिंग, इट कंटेन्स सिमेट्रिक, राइट? अभी एक साइकिल के बाद वेट, I'll come back to this a not equal to 0 कैसे है. We have solved that down. हम लोग ने नीचे किया हुआ है, तुम्हें इक्वेशन से समझेगा, अभी तुम्हें डायरेक्टली नहीं समझेगा. ओके, सो नाउ whatever information we have studied from equation number 1 to 13, we are going to apply that. सिंगल फेज फुल वेव कन्वर्टर RL लोड और RLE लोड में इनपुट वेवफॉर्म ऐसे दिखता है, राइट? एनी डाउट्स इन दिस? ये नॉर्मल नहीं है, मतलब ये साइनसॉइडल नहीं है, इट कंटेन्स हार्मोनिक्स, राइट? तो वेरिएशन किधर आ रहा है? अल्फा टू पाई प्लस अल्फा एंड पाई प्लस अल्फा टू 2 पाई प्लस अल्फा. इसमें एवरेज वैल्यू कितना है? हाँ, एवरेज वैल्यू कितना है? इसका डीसी कंपोनेंट कितना है? व्हाट्स द डीसी वैल्यू ऑफ दिस? 0. सो दैट्स व्हाई A naught इज 0. अरे देखो ना, अल्फा से इट्स गोइंग पॉजिटिव, राइट? अल्फा टू पाई प्लस अल्फा में पॉजिटिव है, पाई प्लस अल्फा टू 2 पाई प्लस अल्फा में नेगेटिव है. जितना पॉजिटिव उतना ही नेगेटिव. तो अल्फा टू 2 पाई प्लस अल्फा में एवरेज वैल्यू कितना है? इट्स गोइंग फ्रॉम 0, लेट्स से मैक्सिमम 10 है, वापस 0 जा रहा है, फिर -10 जा रहा है, वापस 0. एवरेज कितना हुआ? एवरेज मतलब डीसी वैल्यू. अभी समझा A naught 0 कैसे है? ये हाफ वेव सिमेट्री. This is continuous but not constant. and we are assuming that its average value is I naught. I naught मतलब हमारा I out average only. अरे देखो सुनो, in a full wave converter output current is equal to input current is equal to input current during when T1 T2 are on. When T3 T4 are on वो नेगेटिव जाता है, पर पीक उसका सेम रहता है ना. I out का पीक and I in का पीक will be same है. Only thing is I out will be always be positive. तो उसका एवरेज will be positive. We are analyzing input current. समझ में आ रही है बात? और ये I नॉट कैसे है? मैंने बोला ना इसका वैल्यू पॉजिटिव पीक वैल्यू हियर एंड नेगेटिव पीक वैल्यू ओवर हियर सेम एज ये पीक और ये पीक सेम है. ठीक है, दैट्स व्हाट आई मेंट. I naught. Okay, so I naught is equal to I out average or IDC, which is a constant load current. हम लोग assume करते हैं ना constant load current. This is what it is. Now ये हम लोग सिमिलरली लिख सकते हैं ना, सिमिलर टू इक्वेशन नंबर 13. वो वोल्टेज के लिए था, ये करंट के लिए है. I n of t is I0 plus summation of all the terms. हाफ वेव सिमेट्री हमें नीचे आएगा. And Cn, what is, you know Cn, what is it? An square plus Vn square raised to half sin n omega t plus phi n. What is phi n? Phi n is the delay angle of the nth harmonic. So this is equation number A. ये जो equation number A से है ना, that you have in syllabus. This is ये full converter के लिए apply कर रहे हैं ना, इधर से syllabus में है. Where Cn is this, phi n is this, I naught. या I naught value 0 कैसे इधर लिखा हुआ है, बराबर है. From alpha to pi plus alpha, its value is I naught, right? From minus, minus कर रहे इधर. Pi plus alpha to 2 pi plus alpha, its amplitude is I naught. तो खत्म ना, 0. देखो इधर बताया 0 कैसे हुआ है, समझा अभी I naught 0 कैसे है? एक्चुअली वेवफॉर्म से भी दिख रहा है 0 है, but this is mathematically proven. वो I naught टर्म चला गया ना, पहले बता दिया था मैंने, बोला नीचे है इसलिए वेट करो. नाउ यू अंडरस्टूड. नाउ ए एन के भी ऐसे ही है, सेम. ये 1/पाई कैसे आया, पहले ही बता दिया था मैंने. और इसमें 0 to 2 पाई नहीं जाते, अल्फा टू पाई प्लस अल्फा एंड पाई प्लस अल्फा टू 2 पाई प्लस अल्फा. सो इट विल बी I naught cos n ओमेगा t d ओमेगा t. टू एनालाइज इट, इसको सॉल्व करते रहो, एंड रिजल्ट ये है ए एन. ये ना तुम लोग ये क्या करो, लिखना स्टार्ट करो. आई एन ऑफ टी इक्वेशन लिखो, ये वाला इक्वेशन नंबर ए लिखो, एंड राइट व्हाट इज सी एन एंड फाई एन ऑल्सो. राइट डाउन इन योर बुक्स, इट विल बी यूजफुल. So all the students, performance parameters, in order to understand thoroughly, this equation should be known to you. तुम्हारे background रहेगा, ये आया कहाँ से? And how I naught is 0, I have explained below. You don't have to explain that. And what is phi n? Delay angle of the nth harmonic. Between what? Between the source current and the line voltage. बराबर ना? नॉर्मली अगर R लोड होता, R लोड, तो करंट एंड वोल्टेज सेम, डिफरेंस नहीं होता दोनों में. Since it is a RL load, current starts, falling up, delaying by angle of phi. और ये फॉर्चुनेटली आगे जाके देखिए, दिस इज रिलेटेड टू अल्फा फायरिंग एंगल, रिलेटेड टू दैट फायरिंग एंगल. ठीक है, रिटर्न I naught is 0, अंडरस्टूड. an, राइट डाउन द फॉर्मूला फॉर an. देखो इधर से, एक मिनट जरा इधर देखो. नाउ इफ यू सब्स्टिट्यूट इवन वैल्यूज, इवन नंबर्स n 2 4 and 6, इसको सॉल्व करोगे तो इसका इंटीग्रल 0 आएगा. ना हाफ वेव सिमेट्री से 0 है, इसको मैथमेटिकली प्रूव कर सकते हैं. और इफ यू कंसीडर n as 1 3 5 ऑड हार्मोनिक्स, उसका इक्वेशन ये आएगा. Now I am not going into derivation, इसका derivation है नहीं, खाली an का value लिखो. Write down the formula for an in your books. What is I naught? IDC, I out average. Remember that. So minus 4 I naught n divided by n pi into sine n alpha. N alpha. Alpha. What is alpha? Firing angle. Fine. Similarly, that's why we consider only odd harmonics. ऊपर statements बोले थे, यहाँ पे mathematics है prove करने के लिए, right? लिख लिया? Okay. Similarly, Bn. I'm not going into details. You all can do that on your own at your own time. ये Bn का equation लिखो. 4 I naught n pi divided by n pi into cos n alpha for odd harmonics n 1 3 5, and it will be 0 for even harmonics. Correct? अभी Cn का फॉर्मूला लिखा है ना तुम लोग ने, देखो an plus bn square, right? You have written an and bn just now. So इसको स्क्वायर करोगे तो you will get this sin square plus, what is sin square plus cos square? तो वो गया. What remains? 4 I naught upon n pi. तो Cn का ये नवा वाला फॉर्मूला लिखो. अंडरस्टैंडिंग? इजी है ये. ऑल मैथमेटिक्स का पूरा सपोर्ट है मैथमेटिक्स का इसके साथ. No one will ask you the derivations of this, पर ये फॉर्मूला तुम्हें फंडामेंटली पता होना चाहिए. Now what is phi n? Tan inverse of an upon bn. an bn हमें पता है ना क्या है. What is sin upon cos? Tan. माइनस ऑफ tan आएगा, और माइनस ऑफ tan मतलब अभी ये देखो phi n is tan inverse of minus tan n alpha. So what it will be? Tan inverse of tan is angle itself, which is minus n alpha. So phi n is minus n alpha. लिखो ये फॉर्मूला. तो phi n को बोलते हैं डिस्प्लेसमेंट एंगल ऑफ nth हार्मोनिक करंट कंपोनेंट. अगर मेरा फंडामेंटल है, अगर phi 1 है तो दैट विल बी इक्वल टू माइनस अल्फा, सेम एज फायरिंग एंगल. लिखा phi n. तो ये मेरा इक्वेशन बन गया बाय रीराइटिंग इट. आई नॉट चला गया, ये इक्वेशन लिखो. आई नॉट चला गया, राइट? स्टार्टिंग में था ना आई नॉट प्लस, आई नॉट इज गॉन. सो दिस इज आई एन ऑफ टी. नॉर्मली इन द टेक्स्ट बुक्स दे आल्सो मेंशन इट एज और बोलते हैं, इनपुट करंट बोलते हैं ना. सम बुक्स हैव कॉल्ड इट आई ऑफ टी इटसेल्फ. इट ऑल मींस व्हाट वाज दैट Cn ना, Cn के साथ रिप्लेस किया ना वहां पे. Cn is 4 I naught upon n pi sin n omega t plus n alpha. This equation number B. ठीक है? अभी ध्यान से देखो. RMS value of the nth harmonic input current. ये क्या है? ये peak value. I mean this is जैसे Vm रहता है, ये Im है. तो how will you write RMS? Vm by root 2 ना, तो ये Im by root 2. तो ये वाला जो कंपोनेंट है 4 I naught upon n pi डिवाइडेड बाय रूट 2. देखो RMS लिखो. ये होता है ना V sin ओमेगा t. कैसे लिखते हैं हम लोग? Vm sin ओमेगा t, राइट? सिमिलरली करंट भी ऐसे रहता है, Im sin ओमेगा t. समझ रहे हैं तुम्हें? 4 upon root 2 is 2 root 2, right? So write equation number C. 2 root 2 I naught upon n pi. Now what is C1? Cn है तुम्हारे पास. 4 I naught n pi है ना, तो pi 4 I naught upon pi. और what is phi 1? Minus alpha. So phi 1 is displacement angle of fundamental component. जो 1 रहता है ना, वो fundamental रहता है. So displacement angle of the fundamental component of supply current. And what is the negative sign indicates? Negative side will show that the fundamental input current lags behind the source voltage. Okay? अभी RMS value of fundamental current देखो, अभी ये जो लिखा है ना IN of N, ये RMS वैल्यू है ना. अभी N जब भी 1 है तो कितना वैल्यू रहेगा? So write down IN of 1. ये जनरल फॉर्मूला था ना. So IN of 1 will be 2 root 2 I naught divided by pi. Or irrespective of any value, I mean this will be 90% of I naught always. This next component is slightly confusing. I will try to explain it, but let's try start. इधर तक समझ गया? ये D point equation number D. Now ये RMS value of the fundamental current था, मतलब first वाला. Now RMS value of the total input current, including all the values. So it will be summation of all such RMS values, right? बराबर ना? N equal to 1, 2, 3, 4 सारे बराबर है. Ideally, I mean alternatively, IN RMS can also be calculated directly from this formula. 1 upon pi alpha to alpha to pi plus alpha I0 square, I mean I naught square d omega t raised to half. So this if you apply, and this derivation is not there, this if you check it out carefully, if you work out carefully mathematically, that IN of RMS will be equal to I out. तो ये लिखो, IN RMS is equal to I naught. So these equations are required as base. अभी जो लिखवा रहा हूँ black color है. Black color is there in your syllabus. Okay? चलो पहले अभी ये definition मत लिखो, खाली उसका समझ के लो, ठीक है? So what I was saying, blue color is my line voltage. My fundamental current is delayed by pi. अभी पढ़ा है ना हम लोग ने? So that pi is called as displacement angle. So if pi is the angle between the fundamental components of the input current and voltage, then the displacement factor will be cos pi. ठीक है? अभी हम लोग को fundamental चाहिए ना, ये cos phi 1 आएगा ना? So phi 1 is equal to, remember, minus alpha, and cos of minus is cos that only. बराबर है? So लिखो DF displacement factor, long story short. ये समझ रहे हैं ना तुम लोग को? What is dotted line? IN of 1 fundamental component, and it is lagging by phi. और ये क्यों होता है? It's only applicable to converters because of delay angle alpha. हम लोग delay करते हैं ना start, इसमें भी delay होता है. See, सुनो, because we are applying to a converter, input मेरा input current और voltage same होना चाहिए था, right? Starting में it should start from same position, right? Because we delay there, यहाँ पे भी delay होता है in the components. So that's why you can see यहाँ पे लिखा है मैंने cos phi 1 and यहाँ पे लिखा है cos alpha. Alpha is very closely related to that. So write displacement factor as cos alpha. And what is alpha? Finding angle. And what is phi? Displacement angle. Alpha and phi का value equal, हाँ, आप बोल सकते हो. Yes, you can say that. In this case, it will be might be equal in magnitude but opposite in phase. Actually, हाँ, equal नहीं होगा. Equal होगा तो harmonics कम हो गए. You filter out the harmonics. Actually क्या होता है? We normally filter out to pass it through filter circuits, and then we try to remove the harmonics. So ये firing angle और phi जितना close हो गए उतना अच्छा है. Ideally. ये alternate derivation है, but it leads to the same result. तो ठीक है ना? Same ही है. Next, write down input current distortion factor (CDF). इसका definition is IN of 1 divided by IN RMS. IN of 1 का फॉर्मूला क्या है? 2 root 2 I naught upon pi. और IN RMS का फॉर्मूला क्या है? I naught. Just now you have written ना? So what is CDF? 2 root 2 upon pi. Irrespective of anything, एग्जाम में ही आया तो डायरेक्टली यही लिखना है. You'll get full marks because it's a constant, right? It's 90%. Current distortion factor is 90%. लिखा? Input power factor, write down the formula. PF, capital PF, CDF into DF. What is CDF? Current distortion factor, and DF is displacement factor. हमारा करंट डिस्टॉर्शन फैक्टर क्या है? 2 रूट 2 अपॉन पाई, एंड डिस्प्लेसमेंट फैक्टर क्या है? कॉस अल्फा. सो 2 रूट 2 अपॉन पाई इंटू कॉस अल्फा. Is that fine? Now next, harmonic factor or HF or total harmonic distortion. मैं अभी लिखो मत कुछ. I will tell you what to write. So originally the formula is like this: I in RMS. What is I in RMS? RMS value of the total input current. What is I in 1? Fundamental component, right? So it's RMS value of input current minus the fundamental component square divided by I in square raised to half. अभी हम लोग को पता है I in of 1 divided by I in RMS is CDF. So 1 upon CDF square minus 1 raised to half. ये फॉर्मूला लिखो. हार्मोनिक फैक्टर इज 1 upon CDF square minus 1 raised to half. बस याद करने की जरूरत नहीं है ना, CDF याद है ना, तो why to remember something else again? अगर CDF कांस्टेंट है तो हार्मोनिक फैक्टर भी कांस्टेंट है. It's 48%. We can ask you this in oral exam. What is current distortion factor? Explain harmonic factor, total harmonic distortion. लिखा? Remember this formulas, not this. वोल्टेज, अच्छा वोल्टेज रिपल से पहले फॉर्म फैक्टर लिखो. ये पढ़ा हुआ है हम लोग, बराबर? राइट डाउन फॉर्म फैक्टर. वी आर रिविजिटिंग इट. What was the formula? V out RMS upon VDC. Now, for a single phase full wave control rectifier, what was the average value of the output? 2 Vm by pi cos alpha. And what was the RMS value? Vm by root 2. We got these values, right? अब इसमें से average value, RMS value इसमें substitute करो. You'll get the answer. Don't try to remember the final formula. Remember this basic formula. Are you understanding? The red color thing which I have written is meant for RL load. R load के लिए अलग रहेगा, right? But the basic formula remains the same. तो यहाँ पे फॉर्म फैक्टर का भी हम लोग ने कैलकुलेट किया है, but still you do not remember this. Remember only this formula. Next is voltage ripple factor. Voltage ripple factor will be form factor square minus 1 raised to half. खाली ये लिखो. Voltage ripple factor will be form factor square minus 1 raised to half. Okay? Completed? Now, output DC power. Write down quickly. V out average into I out average. PDC or P out? I out average into I out, R out average into, V out average into I out average. Output AC power, V out RMS into I out RMS. अभी आउटपुट की बात कर रहे हैं ना, तो विच पैरामीटर्स दे आर? आउटपुट परफॉर्मेंस पैरामीटर्स. जो इनपुट की बात करता है वो इनपुट परफॉर्मेंस पैरामीटर्स. व्हाट इज एफिशिएंसी? पीडीसी अपॉन पीएसी इंटू 100. Rectification efficiency is PDC upon PAC into 100, and these are the formulas for PDC and PAC. Active input power. देखो, PI, you write down the formula. Only the RMS fundamental component of the input current contributes to the active power input. Why? Average नहीं, only RMS fundamental component, वो भी खाली fundamental, right? So PI will be RMS value of the source voltage. सुनो पहले RMS value of the source voltage, which is V in RMS. RMS fundamental component of the source current, which is IN of 1, and displacement factor multiplication of 3. So write down this. PI is V in RMS into I in 1. Now I in 1 तुम्हें पता है ना क्या है? You know what it is, and you know the formula, and you know where it is coming from. You know what is displacement factor. Actually यहाँ पे displacement factor क्या ठीक है? Displacement factor नीचे मैंने लिखा हुआ है वहाँ पे. No need to remember this formula. ये देखो. नीचे उसका description. I in of 1 is 2 root 2 I naught upon I. And now, what is Vm? Root 2 times Vrms. तो ये रूट 2 और V in RMS कंबाइन कर सकते हैं, बराबर ना? So it becomes 2 Vm IDC upon pi into cos alpha. समझ रहा है? इजी है. So you can remember it this way also. Two Vm IDC. What is IDC? I out average, which is V out average upon R. Reactive power input. Last. Reactive power input QI. इसमें क्या है? सब कुछ सेम है. इंस्टेड ऑफ cos alpha we have sin alpha. Active power, reactive power पढ़ा है ना? Apparent power, power triangle. You remember? वो cos alpha था, ये sin alpha है. So write down that formula, final formula, first and the final. V in RMS I into 1 into sin alpha. QI is 2 Vm IDC upon pi. Is that fine? So these are all the formulas for full converter. Similarly, we have it for semi converter. Now note down this numerical quickly, and you all are going to do it on your own. I am giving it as a home assignment. ये सारे parameters ही find करने हैं. A single phase full converter connected to 230 volts 50 hertz source is feeding a load R equal to 10 ohms in series with a large inductance that makes the load current ripple free. Correct? Load current constant है और L का वैल्यू नहीं दिया. देखो बोला लार्ज इंडक्टेंस है, L का वैल्यू चाहिए भी नहीं, because I out average will be V out average upon R. L आता ही नहीं है. For a firing angle of 45 degrees, calculate the input and output performance parameters of this converter. So what do you mean by performance parameters? Everything whatever we have discussed. So I will help you out in writing the sequence of events, what all things you have to find out. Okay. So first I'm writing blue color over here. First, V out average. I hope you know the formula for it, right? Then calculate I out average. Then next, after I out average, calculate V out RMS. Then point number 4, I out RMS. I out RMS. RMS. Why it is so? Why they are saying? Because of this. I out RMS. PDC. What's the things, right? Calculate rectification efficiency, theta, upon PSC into 100, right? Then next you calculate form factor. By now you will have everything. Then calculate voltage ripple factor. Then current ripple factor will be zero. Why will be zero? Recovery लिखा है ना? I have marked it yellow. Note करा ripple factor directly. Next, we calculate at I of 1. Remember the formula? Then we calculate phi 1 minus 45 degree. 45. Then we calculate displacement factor. Calculate displacement factor. Finally, total harmonic or harmonic factor. Active power, 17 active power and reactive power. So these all things you have to find out for this converter with the information given to you in this sequence. So that will be all for today. Thank you.